The ocean's vibrant coral reefs present some of nature's most spectacular displays, with their colorful formations and diverse marine ecosystems. However, beneath their beauty lies a complex world of biological and chemical processes that make these organisms fundamentally unsuitable and potentially dangerous for human consumption. Understanding what happens when someone consumes sea corals requires exploring marine biology, toxicology, environmental impact, and human physiology. Sea corals, despite their plant-like appearance, are actually animals belonging to the phylum Cnidaria. These fascinating creatures have evolved over millions of years to thrive in marine environments, developing sophisticated defense mechanisms and symbiotic relationships that make them integral to ocean ecosystems, but hazardous to human health when consumed. Understanding sea corals, biology and structure. The nature of coral organisms. Sea corals are colonial animals composed of thousands of tiny polyps, each no larger than a pinhead. These polyps secrete calcium carbonate to form the hard skeletal structures we recognize as coral reefs. The living tissue of corals contains numerous specialized cells called cnidocytes, which house stinging organelles known as nematocysts. These microscopic harpoons are the coral's primary defense mechanism against predators and can cause significant harm to humans who come into contact with them. The coral polyp itself consists of a simple body structure with a mouth surrounded by tentacles. Inside the coral tissue live millions of symbiotic algae called zooxanthellae, which provide the coral with nutrients through photosynthesis while receiving shelter and nutrients in return. This symbiotic relationship is crucial for coral survival and contributes to the complex chemical composition that makes corals unsuitable for human consumption. Chemical composition and toxic compounds. Corals contain numerous bioactive compounds that serve various biological functions but pose serious health risks to humans. These include halotoxin, one of the most potent marine toxins known to science. Halotoxin is found in various coral species, particularly zoanthids. This neurotoxin affects sodium and potassium channels in cell membranes, leading to severe physiological disruptions. Even minimal exposure can cause respiratory distress, cardiovascular problems, and potentially fatal complications. Prostaglandins. Many coral species produce prostaglandin-like compounds that can cause intense inflammatory responses in humans. These chemicals can trigger severe allergic reactions, respiratory issues, and gastrointestinal distress when ingested. Calcium carbonate. The skeletal structure of corals is primarily composed of calcium carbonate, which is indigestible and can cause mechanical damage to the digestive system. Large quantities can lead to intestinal blockages and severe abdominal pain. Heavy metals. Corals often bioaccumulate heavy metals from their environment, including mercury, lead, and cadmium. These toxic elements can cause long-term health problems, including neurological damage, kidney dysfunction, and developmental issues. Immediate physical effects of coral consumption. Gastrointestinal trauma. When coral material enters the human digestive system, the immediate effects are often severe and multifaceted. The hard, calcified structure of coral skeletons can cause mechanical damage throughout the digestive tract. Sharp fragments can lacerate the esophagus, stomach lining, and intestinal walls, leading to internal bleeding and potential perforation. The body's attempt to process indigestible coral material often results in severe abdominal cramping as the digestive system struggles to break down or pass the foreign matter. This can lead to intestinal obstruction, requiring emergency medical intervention to prevent life-threatening complications. Toxic chemical reactions. The various bioactive compounds present in coral tissue trigger immediate toxic responses when ingested. Halotoxin exposure typically begins with gastrointestinal symptoms, including nausea, vomiting, and severe diarrhea. As the toxin is absorbed into the bloodstream, it begins affecting cellular function throughout the body. The disruption of cellular ion channels caused by coral toxins leads to widespread physiological chaos. Muscle cells become hyperexcitable, potentially causing painful spasms and contractions. Cardiac muscle is particularly vulnerable, with toxin exposure potentially leading to dangerous arrhythmias and cardiovascular collapse. Inflammatory responses. The immune system's response to coral consumption is typically swift and severe. The presence of foreign proteins and toxic compounds triggers a massive inflammatory cascade, potentially leading to anaphylactic shock in sensitive individuals. This systemic inflammatory response can cause rapid swelling of tissues, particularly in the throat and airways, creating a life-threatening emergency. Prostaglandin-like compounds in coral tissue amplify these inflammatory responses, causing intense pain, swelling, and potential organ dysfunction. The combination of mechanical trauma, toxic exposure, and inflammatory reaction creates a perfect storm of medical complications. Neurological and systemic effects. Neurotoxic impact. Many coral species contain potent neurotoxins that directly affect the human nervous system. These compounds can cross the blood-brain barrier, leading to severe neurological symptoms, including confusion, seizures, and altered consciousness. The disruption of normal neural transmission can cause temporary or permanent neurological damage. Victims of coral poisoning often experience severe headaches, dizziness, and sensory disturbances. Vision problems, including blurred sight and color perception changes, are common as toxins affect the optic nerve and visual processing centers in the brain. Cardiovascular complications. The cardiovascular system is particularly vulnerable to coral toxins. Palotoxin and related compounds directly affect heart muscle cells, potentially causing dangerous changes in heart rhythm and blood pressure. Some victims experience severe hypertension followed by dangerous drops in blood pressure as the toxin overwhelms the body's regulatory mechanisms. Cardiac arrest is a documented complication of severe coral poisoning, making immediate medical intervention crucial for survival. Even non-fatal exposures can cause long-term cardiovascular problems, including chronic arrhythmias and reduced heart function. Respiratory distress. Coral toxins frequently affect the respiratory system, causing difficulty breathing and potential respiratory failure. The toxins can cause inflammation of the airways, leading to swelling that restricts airflow. This is compounded by the direct toxic effects on the muscles involved in breathing. Many coral poisoning victims require mechanical ventilation support as their respiratory systems become compromised. The combination of airway inflammation, muscle weakness, and central nervous system depression can create life-threatening breathing difficulties. Long-term health consequences. Permanent organ damage. Survivors of coral poisoning often face long-term health consequences that can persist for months or years after the initial exposure. The kidneys are particularly vulnerable to coral toxins, with many victims developing chronic kidney disease or complete renal failure requiring dialysis or transplantation. Liver damage is another common long-term complication, as this organ bears much of the burden of detoxifying coral compound from the blood. Chronic liver dysfunction can affect the body's ability to process medications, produce essential proteins, and maintain proper metabolism. Neurological sequelae. The nervous system effects of coral toxins can persist long after the initial exposure. Many survivors report ongoing cognitive difficulties, including problems with memory, concentration, and decision-making. These neurological deficits can significantly impact quality of life and ability to function in daily activities. Peripheral neuropathy, characterized by numbness, tingling, and pain in the extremities, is a common long-term complication. This condition results from toxin-induced damage to peripheral nerves and may be partially or completely irreversible. Psychological impact. Beyond the direct physical effects, coral poisoning can have significant psychological consequences. The trauma of severe illness and potential near-death experience often leads to post-traumatic stress disorder, PTSD, anxiety disorders, and depression. The uncertainty surrounding recovery and potential long-term effects creates ongoing psychological stress for survivors and their families. Many require extensive counseling and psychological support to cope with the aftermath of coral poisoning. Environmental and ecological implications. Ecosystem destruction. The harvesting or consumption of corals has devastating environmental consequences that extend far beyond the immediate health risks to humans. Coral reefs are among the most biodiverse ecosystems on Earth, supporting approximately 25% of all marine species despite covering less than 1% of the ocean floor. Each coral colony represents decades or centuries of growth, and their destruction for consumption purposes eliminates crucial habitat for countless marine organisms. The loss of coral cover reduces fish populations, affects local fishing communities, and disrupts the delicate balance of marine ecosystems. Climate change acceleration. Coral reefs play a crucial role in carbon sequestration and climate regulation. Healthy coral ecosystems help maintain ocean chemistry balance and protect coastal areas from storm damage and erosion. The destruction of coral reefs for any purpose, including consumption, accelerates climate change effects and increases vulnerability to extreme weather events. The symbiotic algae within corals are significant contributors to ocean primary productivity. Their destruction reduces the ocean's capacity to absorb carbon dioxide and produce oxygen, contributing to global climate change acceleration. Biodiversity loss. Coral reef ecosystems support an incredible diversity of marine life, from microscopic organisms to large predatory fish. The consumption of corals eliminates essential habitat and food sources for these organisms, leading to cascading effects throughout the marine food web. Many species that depend on coral reefs are already threatened by climate change, pollution, and habitat destruction. Additional pressure from coral harvesting pushes these species closer to extinction and reduces the overall resilience of marine ecosystems. Cultural and historical context. Traditional uses and misconceptions. Throughout history, various cultures have attributed medicinal or nutritional properties to marine organisms, including corals. Some traditional medicine systems have incorporated coral-derived substances, often without understanding the significant health risks involved. These historical uses were typically based on limited understanding of marine biology and toxicology. Modern scientific research has clearly demonstrated that the risks of coral consumption far outweigh any perceived benefits, making these traditional practices dangerous and inadvisable. Modern misconceptions. In contemporary times, social media and internet misinformation have sometimes promoted coral consumption as a health trend or survival technique. These dangerous misconceptions ignore the substantial scientific evidence regarding coral toxicity and the severe health consequences of consumption. The romanticization of natural or traditional remedies sometimes leads people to overlook the serious dangers associated with consuming marine organisms like corals. It's crucial to understand that natural does not equate to safe, particularly when dealing with organisms that have evolved potent chemical defenses. Medical treatment and emergency response. Immediate emergency care. Coral poisoning requires immediate emergency medical attention, as the rapid progression of symptoms can quickly become life-threatening. Emergency responders must be prepared to address multiple simultaneous medical crises, including respiratory failure, cardiovascular collapse, and severe allergic reactions. Initial treatment focuses on stabilizing vital signs and preventing further toxin absorption. This may involve gastric lavage to remove remaining coral material from the stomach, though this procedure carries its own risks given the potential for sharp fragments to cause additional tissue damage. Activated charcoal administration may help absorb some toxins, though its effectiveness against coral-specific compounds is limited. More importantly, supportive care, including intravenous fluids, oxygen therapy, and cardiac monitoring, is essential for patient survival. Advanced medical interventions. Severe coral poisoning cases often require intensive care unit treatment with advanced life support measures. Mechanical ventilation may be necessary for patients experiencing respiratory failure, while cardiac arrhythmias may require pharmacological intervention or electrical cardioversion. Hemodialysis or hemoperfusion might be employed to help remove toxins from the blood, though the effectiveness of these treatments varies depending on the specific toxins involved and the timing of intervention. Pain management becomes a significant challenge, as many standard analgesics may be contraindicated due to organ dysfunction. Long-term medical management. Survivors of coral poisoning require extensive, long-term medical follow-up to monitor for and treat ongoing complications. Regular kidney function tests are essential, as renal damage may progress even after the acute phase of poisoning has resolved. Neurological assessment and rehabilitation may be necessary for patients experiencing ongoing cognitive or motor deficits. Physical therapy, occupational therapy, and speech therapy may all play roles in helping survivors regain function and adapt to permanent disabilities, prevention, and risk reduction. Education and awareness. The most effective approach to preventing coral poisoning is comprehensive education about the dangers of coral consumption. This education must target not only the general public, but also healthcare providers, who may encounter patients with coral-related injuries or poisoning. Public health campaigns should emphasize that corals are toxic marine animals, not edible plants or safe natural remedies. Clear messaging about the severe health consequences of coral consumption can help prevent accidental poisonings and discourage intentional consumption. Marine conservation efforts. Protecting coral reefs through conservation efforts serves the dual purpose of preserving crucial marine ecosystems while reducing human exposure to coral toxins. Marine protected areas, water quality improvement initiatives, and climate change mitigation efforts all contribute to coral reef health. One significant danger in marine environments is the difficulty in accurately identifying coral species and distinguishing them from other marine organisms. Many people cannot reliably differentiate between corals and other marine life forms, such as sea anemones, sponges, or marine plants. This identification challenge is compounded by the fact that toxicity levels vary dramatically between different coral species and even between different parts of the same coral colony. Some coral species may appear similar to others, but contain vastly different toxin profiles, making visual identification an unreliable safety measure. Seasonal variations, environmental stressors, and geographic differences all affect coral toxin production, meaning that the same species may be more or less toxic depending on when and where it is encountered. This variability makes it impossible to predict safe exposure levels based on species identification alone. Psychological and social impacts. Community and family effects. Coral poisoning incidents often have far-reaching effects beyond the immediate victim. Families may face enormous medical expenses, lost income from prolonged illness, and the emotional trauma of watching a loved one suffer severe health complications. In communities where traditional medicine practices have historically included coral use, poisoning incidents can create conflict between traditional healers and modern medical practitioners. Educational efforts must be culturally sensitive while clearly communicating the dangers of coral consumption. The social stigma associated with making such a dangerous choice can also affect victims and their families. Some individuals may delay seeking medical treatment due to embarrassment, potentially worsening their condition and reducing chances of full recovery. Economic consequences. The economic impact of coral poisoning extends beyond immediate medical costs. Victims often require extended periods of medical care, rehabilitation services, and ongoing monitoring for chronic complications. These costs can be devastating for individuals and families, particularly in areas with limited health insurance coverage. Lost productivity from illness, disability, or death creates broader economic impacts on communities and employers. The specialized medical care required for coral poisoning victims may not be available locally, requiring expensive medical transportation and treatment at distant facilities. Tourism industries in coral reef areas may also be affected by poisoning incidents, as negative publicity can deter visitors and reduce economic opportunities for local communities. This creates additional incentive for proper education and prevention programs. Educational challenges and cultural sensitivity. Developing effective education programs about coral toxicity requires understanding and respecting local cultures while clearly communicating health risks. In some cultures, Challenging traditional beliefs about coral properties may be met with resistance or skepticism. Educational materials must be developed in multiple languages and formats to reach diverse populations. Visual aids, community presentations, and partnerships with local leaders are often more effective than written materials alone, particularly in areas with limited literacy rates. Healthcare providers in coral reef regions require specialized training to recognize and treat coral poisoning. This training should include cultural competency components to help providers work effectively with patients who may have consumed corals based on traditional beliefs. Advanced treatment strategies and research, experimental therapies, and antidotes. Current research into coral poisoning treatment focuses on developing specific antidotes for major coral toxins. While no specific antidote exists for palotoxin, researchers are investigating various approaches, including antibody-based treatments and cellular membrane stabilizers. Plasmapheresis, a procedure that removes toxins from the blood plasma, has shown promise in some severe cases. This treatment involves removing the patient's blood plasma and replacing it with donor plasma or albumin solutions, potentially reducing circulating toxin levels. Hyperbaric oxygen therapy is being investigated as an adjunctive treatment for coral poisoning. The increased oxygen levels may help support cellular metabolism and reduce tissue damage, particularly in cases where oxygen delivery is compromised by cardiovascular effects. Prognostic factors and outcome prediction. Medical researchers have identified several factors that influence outcomes in coral poisoning cases. The amount of coral consumed, the species involved, the time delay before treatment, and the patient's overall health status all affect prognosis. Early recognition and treatment significantly improve outcomes, emphasizing the importance of public education about coral toxicity. Patients who receive supportive care within the first few hours of exposure have much better survival rates and fewer long-term complications. Certain laboratory values can help predict severity and guide treatment decisions. Elevated muscle enzymes, kidney function markers, and cardiac indicators help healthcare providers assess organ damage and adjust treatment accordingly. Long-term follow-up and rehabilitation. Survivors of coral poisoning require comprehensive, long-term medical follow-up to monitor for delayed complications and provide appropriate rehabilitation services. This follow-up typically includes regular assessments of kidney function, cardiovascular status, and neurological function. Physical therapy may be necessary for patients who experience muscle weakness or coordination problems following coral poisoning. Occupational therapy helps individuals adapt to any permanent disabilities and return to daily activities as much as possible. Psychological counseling and support services are important components of long-term care, as many survivors experience anxiety, depression, or post-traumatic stress related to their poisoning experience. Family counseling may also be beneficial to help loved ones cope with the ongoing effects of the incident. Environmental forensics and pollution impacts. Coral toxin concentration factors. Environmental factors significantly influence coral toxin production and concentration. Water temperature, salinity, pollution levels, and seasonal changes all affect the biochemical processes within coral polyps that produce toxic compounds. Stressed coral colonies often produce higher concentrations of defensive toxins as a survival mechanism. Climate change effects such as ocean acidification and rising temperatures are causing widespread coral stress, potentially increasing toxin concentrations in coral populations worldwide. Pollution from agricultural runoff, sewage, and industrial sources can also affect coral toxin production. Some pollutants may act as stressors that increase toxin synthesis, while others might interfere with normal coral physiology in unpredictable ways. Bioaccumulation and food chain effects. Coral toxins can bioaccumulate in marine organisms that feed on coral tissue or live in close association with coral reefs. This bioaccumulation creates additional pathways for human exposure beyond direct coral consumption. Fish that feed on coral polyps or algae growing on coral surfaces may concentrate coral toxins in their tissues. While most coral-eating fish have evolved mechanisms to handle these toxins, the accumulated compounds can still pose risks to humans who consume these fish. Global health policy and regulation. International coordination efforts. The global nature of coral reef ecosystems and marine transportation requires international coordination in addressing coral-related health risks. Organizations such as the World Health Organization and Food and Agriculture Organization have developed guidelines for marine food safety that specifically address coral consumption risks. International trade regulations help prevent the commercial distribution of coral products intended for consumption. However, enforcement of these regulations can be challenging, particularly in areas where traditional use practices persist. Diplomatic efforts to protect coral reefs often include health and safety components alongside environmental protection measures. These comprehensive approaches recognize the interconnected nature of environmental and human health issues. Public health surveillance systems. Effective surveillance systems for coral poisoning incidents help identify patterns and improve prevention strategies. These systems require coordination between healthcare providers, public health agencies, and environmental monitoring organizations. Rapid reporting systems allow health authorities to respond quickly to coral poisoning outbreaks and implement appropriate public health measures. This is particularly important in tourist areas where visitors may not be aware of local marine hazards. Data collection from coral poisoning incidents contributes to ongoing research into treatment strategies and risk factors. Standardized reporting protocols help ensure that valuable information is captured and shared among the global medical community. Future research directions and technology. Biotechnology applications. Advances in biotechnology are opening new avenues for coral toxin research and potential therapeutic applications. While corals themselves remain dangerous for consumption, their toxic compounds may have pharmaceutical applications when properly purified and administered under controlled conditions. Genetic engineering techniques are being used to study coral toxin production mechanisms and potentially develop more effective treatments for poisoning incidents. Understanding how corals synthesize these compounds may lead to better antidotes or preventive measures. Biosensor technology development may eventually allow for rapid field testing of coral toxin levels, helping researchers and safety officials assess risks in different coral reef areas. Diagnostic technology advances. Rapid diagnostic tests for coral toxins could significantly improve treatment outcomes by allowing faster identification of poisoning cases. Current diagnostic methods rely primarily on clinical symptoms and patient history, which can delay appropriate treatment. Point-of-care testing devices that could quickly detect coral toxins in blood or urine samples would be particularly valuable in remote areas where coral reefs are common, but advanced medical facilities are limited. Imaging technology advances may also help assess internal damage from coral consumption more accurately, allowing for better treatment planning and outcome prediction. The ongoing research and technological advances in this field continue to reinforce the fundamental message. Coral consumption is extremely dangerous and should be avoided completely, while our growing understanding of coral biology and toxicology helps us better protect both human health and marine ecosystems. Families, particularly in areas with limited health insurance coverage. Lost productivity from illness, disability, or death creates broader economic impacts on communities and employers. The specialized medical care required for coral poisoning victims may not be available locally, requiring expensive medical transportation and treatment at distant facilities. Tourism industries in coral reef areas may also be affected by poisoning incidents, as negative publicity can deter visitors and reduce economic opportunities for local communities. This creates additional incentive for proper education and prevention programs. Educational challenges and cultural sensitivity. Developing effective education programs about coral toxicity requires understanding and respecting local cultures while clearly communicating health risks. In some cultures, challenging traditional beliefs about coral properties may be met with resistance or skepticism. Educational materials must be developed in multiple languages and formats to reach diverse populations. Visual aids, community presentations, and partnerships with local leaders are often more effective than written materials alone, particularly in areas with limited literacy.